So I'm going to first start by reading through the question. So the elevation and plan of 3 beauty products in mutual contact are shown. A 3D graphic of the cylindrical lipstick, a spherical cream container and perfume bottle in the form of a square base pyramid is shown. So here's the 3 solids. Part A, draw the given elevation and plan shown all constructions. So I'm going to start with one solid at a time, right? I'm going to do the truncated square base pyramid. So A, the size of the bottom is 65. Okay, here's the elevation of it. Height is 60. This square here is size 22 because the cylinder inside is tangential to it, and you see the 22 there. I'll give you a quick look what it looks like in 3D. So there's the model in 3D, there's the plan view of it, and there's the elevation. So I'll start drawing that there. So that size there, that square is 22. The height then, the cylinder goes up in elevation. I want you to have a moment, check it yourself as I won't be there. 25. Okay, so that's the plan and elevation done of the truncated pyramid. So the next we have to do is the sphere. Now notice the way it's cut by the horizontal plane. It has a radius of 32 in plan. Okay, so it's radius 32 and it's tangential to this surface here that appears as an edge. So I'll give you a look in 3D. So there's the sphere and then it's cut by the horizontal plane, so you see the cutting after it. Alright, now the distance, okay, if I open up the sketch, the distance between the extreme generator and the center point is 32 and it lies on a line that makes 90 degrees to the edge of the face, otherwise it's not tangential, and the center point is up 30 as shown by the question. So I'll start that there. Okay, so I'm going to mark up 30, light line across. Now I have to line up my set square with the edge of the pyramid. Going to mark out 32 millimeters from the edge, 32 millimeters, okay, and then I'm going to draw in a line parallel to the edge here. Now that contains the center point. Now the reason why you don't bisect the angle as previous questions is because the sphere is cut by the horizontal plane. Okay, so if I just show you what would happen if we bisected it. So if we bisected it, alright, the bisector misses the center point of the sphere. Okay, and the reason it misses the center point of the sphere is because in order for the bisector of the angle to work, alright, it has to be, okay, the center point to the edge has to be the same distance as the center point to the XY line, and it's not. So that's why bisecting the angle there wouldn't work. Right, so there's our center point. Okay, right there, remember, it's 32 millimeters out from the edge of the pyramid. And then to get the point of contact, we're going to draw a line at 90 degrees to the edge of the pyramid from the center point. So there's the point of contact. We can draw in the sphere in elevation. So there we have it there. Then to get it in plan, we can drop the point down, go across here. I think for the top, the line here is 15 down. So I can go down 15. Heavy line across. The radius of the sphere remains the same, okay, in plan. Now, if I bring up the SOLIDWORKS model, okay, let's exit that. So there's the plan of all the solids there. All right, just to go through something here, this what you call it circle here is brought straight down from elevation. It appears as a line, so you just drop it straight down to get the radius of that. And then this bit of hidden detail is when the sphere is cut by the horizontal plane. So what we're going to do is, look, we're going to drop this point down here. So that's the radius of one of the circles in plan. And then the hidden detail one. Okay, we simply draw where the circle appears at the XY line, we bring that down, and that's hidden detail in plan. So we can bring the point of contact down, and then heavy. Now, to get what you call it, the center of the cylinder, okay, in elevation, two circles, the distance between their centers is equal to the sum of their radii. So look, the cylinder and the sphere, their center point is the distance between their two radii added together, and the center point of the sphere is up the radius from the XY line. So what I'm going to do is I'm going to take my set square, I'm going to add on 16, go up 16 from the XY line. Swing my compass. There's the center point. I'm going to draw in my sphere in elevation. The point of contact lies in a line joining their centers. So there's the point of contact in plan that exists literally right down here. That's the point of contact there. So I'll prove that to you now. So there's the points of contact there, and in plan they're just simply straight down. Look, they're just straight down and lie in the center. So that's where they are in plan. The radius of the cylinder remains the same, so I can drop this down. The size of it is 86 in total, if I remember correct. So 43 up and below from the center line. And then the angle in plan there is across from the sphere. And 30 degrees here. So that's part A and B of the questions of the question done. Now we have to draw the development of the truncated square base pyramid. So all four sloping surfaces of the development. So what they're referring to is 1, 2, 3, and the one behind it, the fourth one. Right, so I'm going to show you what the development looks like. So I'll just scroll down here. So that's the development there, those four surfaces. So all four of them folded out. Now, every line on the development has to be a true length. Okay, so I need to see the true length of this line here. Okay, and in elevation, that is not a true length because it's sloping away from us, that line. So when you look straight in at that in elevation, you don't see the true length of that because you're not looking perpendicular to it. Neither in plan, you're not looking perpendicular to that line. Your eyesight is not making a right angle to that line. So what we're going to have to do to find the true length is we're going to have to rotate the line. Okay, see with the compass there, we rotate the line until it's parallel to the XY line in plan. Okay, and when it's parallel to the XY line in plan, you're looking perpendicular to it in elevation because it's on the vertical plane, and then it will be a true length there. Okay, and we can use that to construct the first development. So we'll get going at that there. So I'm going to pause and label all these points. So I'm going to draw a line parallel to the XY line in plan. Okay, I'm going to take my compass here and I'm going to swing tree to B onto the XY line. I'm going to bring it back up to the XY line. Okay, I'll repeat that there. I'm going to swing tree to B onto a line until it's parallel to the XY line. Then I'm going to bring it up until it touches the XY line elevation. So that's B1, B is moved, tree hasn't moved. And then I'm going to join B1 to tree. Okay, so that's the true length of 3 to B. Now, I can do this wherever I want on my page. Right, A to B is 65, and that is the true length because A to B is on the XY line elevation, so A to B in plan is the true length. So I'm going to mark 65 here. Might not have enough room for that. Hope I do. So I'm going to get my compass now, and I'm going to take the true length of 3 to B, and I'm going to swing from these 2 points. Now, somewhere along these arcs lie point 1 and 3. A to 1 is the same length as B to 3. Alright, the distance between 1 and 3 is 22, okay, because it's parallel to the XY line in plan, so it's a true length in elevation and vice versa. So I'm going to get the centre of this line AB by bisecting the line. So take my compass, set it to any length past halfway, swing from both ends of the line, and here's the centre line. So there it is there. Then I'm going to mark 11 either side of that line as the square is 22 in size. I'm just going to bring the points up. So that's point number 1. It's point number 3. So they join together. A joins to B as a dashed line. It's a folded line. Now, so 4 more of those surfaces to do. So to get point 3, or sorry, not point 3, right, that's 1, 3. Now I need 3 to 4. So I'm going to take the length of 3 to 4 here. It's a true length there. So somewhere along here lies 4. But where exactly? Well, if I had a line 3 to A, okay, on the surface, right, on this surface, I could find 3 by swinging 22. Okay, swinging 22 and swinging the true length of this line, okay, and it'd intersect to find, swinging the true length of that line intersect to find 3. Well, every line on the development is a true shape, so I can join A to 3, so that's a true length, and look, B to 4 here in plan is the exact same. They're the exact same size there because all the 4 faces are symmetrical. So I can take the length of A to 3, swing from B, so there's point 4. Now, if I want to find point C, I'm going to take B to C in plan because it appears as a point in elevation, so it's a true length in plan. I'm going to swing from B, and then I'm going to take the true length. Look, I'm going to take this line here, A to 3, because look, essentially, look, watch this, A to 3 in plan is the same as 3 to C. Okay, and I'm looking to find point C. So I'm going to take A to 3, with my compass, I'm going to swing from 3, where they intersect, that's point 3 in plan, or point C rather, point C, sorry. Point C, and they're going to join together. Now I want to get point D, okay, and I need to get point 2. So I'm going to take 4 to 3, okay, it's the same, they're all the same. Swing from 4. Okay, I'm going to take the true length of 4 to 3 and swing from C. Swing from C. Okay, because C to 2 is the exact same length. Look, the exact same length there. They're all the same. So that's why I can do that. That's point 2. They join together. Okay, I want to get point D now. I'm going to take C to D in plan, as it's a true length because it's parallel to the XY line in elevation. So somewhere along there is point D. I can take the true length of B to 3 here from my development, because 2 to D is the same length as B to 3. So I can join them together. And now I'm going to do the other one over here just so we can see better. Alright, so 1 to 3, I'm looking for a point number 2 now, again, where they join. So I'm going to swing 1 to 2 from there. I'm going to swing A to 3. So I'm going to join them together. Then I'm going to take the length of A to B, swing from here. Remember, I'm looking for a point D. Okay, then I'm going to take the true length of 3 to A, swing from 1, or I could take the true length of 1 to A and swing from here, and where they be intersect will be there. And that's the development done.